Hey there, welcome back to another video. Today we're going to walk you through testing resistance and voltage on a 480E, and we're going to show you how to do that with the transmission fully assembled, whether it's in the vehicle and you're trying to diagnose an issue, or if you're out and about looking on Craigslist or Facebook or at a swap meet and you have your multimeter with you and you want to determine, for purposes of buying a good use transmission to replace a bad transmission with, you want to see if there's any problems with the electrical or electronics. So first we're going to show you how to test the case connector. So via the case connector you can test all your solenoids, so that is your shift solenoid A and B, your electronic pressure control solenoid, or aka force motor, as well as your PWM solenoid. And then I'll show you how to test your speed sensors. You have your input speed sensor, and then you have your output speed sensor, which is going to be your vehicle speed sensor in a two-wheel drive unit in a 4x4 480E. The speed sensor there is going to be in the transfer case for vehicle speed. Unless you have a 9193, then it is going to be in the transfer case, but you'll still have a rear speed sensor. So this way you'll have the information you need to test those, and then from there I will show you how to test your pressure switch manifold assembly. I'll explain a little bit about how that works, the role that it plays in the functioning of the transmission, and the interaction and relationship it has with the manual lever position sensor, because they're both integral in telling the computer, communicating with the computer, the range that has been selected by the driver via the shifter. So anyway, let me reposition a little bit, then we'll get started. So in order to carry out this testing, you want to have obviously a multimeter, and it also helps if you have a set of alligator clips, because you're going to want to have them when you're trying to put the little leads here on the pins. That can get real cumbersome and kind of clunky unless you have alligator clips, then it makes it a lot easier, especially when you go to test the vehicle speed sensor. The other thing you're going to want to have is some means to turn the output shaft. So here we have a slip yoke. If you're doing this with the trans in the vehicle and you're trying to test the speed sensor, that's why we have the slip yoke here. You're obviously going to have your drive shaft. So for purposes of doing that test in the vehicle, you want the entire car truck up on all four jack stands, and you want the transmission put into neutral. And you can do that either through the column shifter or directly here on the selector shaft. And then the other thing you're going to want to have is a pencil with an eraser, or something like this. Okay, you could use a drift punch too, but I like to use a pencil with an eraser because what we're going to do is use that to actuate the pressure switches, so that we can then take resistance readings for each one and to inform if they're working or not. Alright, going to reposition the camera once again so we have a kind of eye-level, face-on view of that case connector. I'll walk you through the different pins and what they are, and then we'll start testing the solenoids through the connector. Alright, now that we have a nice up-close personal view of the case connector, let's go over the pin configuration. So you have 11 total pins, which is true for all units 1994 and forward. 9193 is a little bit different, but the differences aren't material, and the harnesses that are available now will service all years from 1991 up into, I think, 2002, 2003, where then a different harness is used owing to the difference in the connector for the EPC. But again, that's not really germane here, it's just more anecdotal. So let's go over the pin configuration starting from the top row. So you have 4 pins there. From left to right, you have the 2 pins for shift solenoids A and B ground, and then you have the next 2 pins for the EPC high and low. And then that pin on the far left, kind of in a row by itself, that's going to be your 12-volt signal pin. And then the pin immediately below that, along with the one to the right of that pin in the next row down, or I should say last row, is going to be here for your transmission fluid temperature sensor. So the pin on the far left there on the bottom row is going to be the COM pin that the sensor uses to send the information to the PCM. And then the pin to the right of that is going to be your 5-volt power. Then the next 3 pins are for the pressure switch manifold assembly itself. So they correspond to circuits A, B, and C on the manifold. And you'll see that a little bit later when we test the pressure switch manifold assembly. And then the last pin on the far right is going to be for your PWM solenoid. Alright, so let me back the camera up a little bit more, and we can go ahead and start our testing. For shift solenoids A and B, we want to see 20 to 22 ohms for resistance. For the EPC or force motor, we want to see between 4 and 5.5. And then for the fluid temperature sensor, we want to see in that 4 to 6 range of resistance. And then lastly, for the PWM solenoid, we're looking at between 9 and 11 ohms. All right, so turn your multimeter on, set it to ohms. And then I'm going to bring the meter a little bit closer, make sure that it's not caught in the glare. And then we're going to go ahead and start with the shift solenoid. So I'm going to put the power on the 12 volt pin here. That's that pin all by itself. And then I'm going to go ahead and put the ground on shift solenoid A, which is going to be the top left pin. So this is going to be a little bit tricky because I've got the tripod in the way, but I'll do the best I can. And basically seeing what comes up on the meter is going to be most important. Alright, so we got 21.4 ohms. That's going to be shift solenoid A. And then we'll do shift solenoid B. Looks like we're at 21.1 ohms, 21, 21.1. Alright, now we're going to go ahead and test the electronic pressure control solenoid. So I'm going to take the probes and I'm going to stick them on both the high and the low pin. So 4.5, 4.6, 4.5. So that looks good to me. And now we're going to test the transmission fluid temperature sensor. Let me get my probes in there. Oop. Looks like 4.07. Now to test the PWM solenoid, I'm going to put the power probe back on the 12 volt signal pin. And then I'm going to put the ground on the far right pin on the bottom row, which is the PWM solenoid ground. And I had it there and lost it. So it's like 11, 10.9, 10.8, 10.9. Okay. Alright, that was a little sloppy, but you get the idea. Basically, what we wanted to see was resistance within specification. That's what we saw. Now, I'll go ahead and flash a chart with all the different codes that correspond to each of these solenoids, and as well as the pressure switch manifold assembly. But suffice to say, if you get codes for solenoids, the first thing you want to do is conduct this kind of testing. That'll tell you if the codes are either legitimately solenoid based or, could be something else, could be valve body too. Now what I'm going to do is I'm going to set up the camera again and we'll transition over to testing the speed sensor. We'll show you how to do that, and then from there we'll get into the pressure switch manifold assembly. Alright, now we're going to test the speed sensor. So we have the probe set up on the vehicle speed sensor, which is the rear speed sensor, and any two-wheel drive 4L80. If you have a 4x4 unit, your vehicle speed sensor is going to be in the transfer case. 9193, they had all three speed sensors active, so that means it had an input speed sensor, an output speed sensor, and then a vehicle speed sensor in the transfer case for all 4L80Es, 91 through 93. 94, they eliminated the rear speed sensor in the transmission, and they just went with the input speed sensor and then the sensor in the transfer case. Alright, so first things first, you want to set your multimeter from ohms to volts. Okay, because how the speed sensor works is it's basically a magnetic pickup, and it's going to be reading a reluctor gear rotating inside the transmission as the vehicle's moving, and it's going to take that reading and convert that into voltage, which that voltage gets sent to the PCM, which then converts that voltage to a vehicle speed, and it uses that information in conjunction with all the other data streams it's getting from all the other sensors in the transmission and elsewhere to command the transmission, telling it what to do, when to shift, and managing all the different governance and control functions within the transmission. So if the speed sensor is not working, if there's an interruption of voltage signal to the PCM from the vehicle speed sensor, then you're going to have no upshift out of first gear. You'll have reverse, you'll have first, and nothing else. So if you don't have a multimeter for whatever reason, you find yourself in this predicament, what you could do is just simply swap the speed sensors. In the 4L80, they're exactly the same. So just take the rear speed sensor and put it in the front position and vice versa. And again, this is for a two-wheel drive vehicle. And if suddenly you have upshift, but you have codes coming in that would indicate a problem with the input speed sensor, you found the problem. Now, if you have the multimeter, then you can do this test. But one thing I might recommend just in case is to have speed sensors extra in your vehicle. Same with the manual lever position sensor, just in case you need to, real quick crawl underneath and swap speed sensors out. I mean, they're not very expensive, and you can just put them in a bag somewhere and have them just in case you need them. All right, so how you're going to do this test with the trans in the vehicle is you're going to put the transmission up on all 4 jack stands, and then you're going to place the shifter into neutral, because you want to spin the drive shaft, because that's what's going to ultimately spin the reluctor gear that is pressed onto the output carrier, and that reluctor gear is going to give the speed sensor the input pickup that it needs so that it can then turn that into voltage and send that signal to the PCM. So we're going to spin the drive shaft or / output shaft. You're going to spin the drive shaft if you're doing this in the vehicle, and then what we want to see is voltage rise based on how fast we're spinning the drive shaft. And we also want to see some variance. If the speed sensor doesn't generate any voltage other than what you see on the meter right now, then you can conclude it's probably dead. If it's generating voltage but it's not varying at all, then you can conclude it's non-functioning. Alright, so start by spinning the drive shaft in the direction of engine rotation, making sure you get a little bit of speed, a decent amount of speed on it, some good momentum. You want to see that voltage vary. Now, we're not going to see anywhere near the amount of voltage we would if the vehicle was moving and operating, but that's not critically important. What's important is that we're seeing some voltage being generated, and the faster I spin the drive shaft, the more voltage I generate. So that's basically an indicator that the speed sensor is working, because it's going to be almost impossible for you to spin this thing like this at the same rate perfectly. I mean, it's just we're not machines, so you don't really have to worry too much about introducing variability consciously. You're going to do it by virtue of spinning the shaft and just varying some work effort. So anyway, I think one of the leads may have come undone. But that's how you test these. If you get no reading, or let's just say it goes up to, 0.05 and stays there no matter how aggressively you spin your drive shaft, then chances are the speed sensor is no good. So the last thing I'll talk about today is the pressure switch manifold assembly. So this works in partnership with the manual lever position sensor to inform the PCM exactly what range or gear has been selected by the driver. Without both of these things working together properly, the computer is never going to get the whole picture. So the pressure switch manifold assembly consists of 3 circuits labeled A, B, and C, and 5 pressure switches. So I'll go ahead and post a chart so that you can use that chart to follow along as we go through the testing. But basically, and this chart, by the way, was something that Vortec iRock had posted on a thread in LS1 Tech. So I want to make sure I give him credit, because it's really the only chart that I have seen, including the ATSG manual, which doesn't have anything like it, that very clearly and completely lays out exactly how this thing works, and also gives you the information you'd need to conduct your testing. So I'll flash that on the screen. You'll have it so that as we go through the testing, you understand what's happening and you can refer to it as we go along. But anyway, the assembly consists of basically a combination of a steel front plate and a plastic housing. And here you have your 3 circuits, again, A, B, and C. And here are the 3 pins, and the labels are in roughly the position of the pins themselves. And then each of these pressure switches have their own label, and I'll try to get it close so you can see them. but it still may be difficult. But they are as follows. This is going to be your drive 4 pressure switch, or pressure switch D4. And if you could see it, the label's right there. Hey, like I said, I don't know if the camera's picking that up or not. But anyway, here is your low pressure switch. That's going to be this one here. And this is going to be your park reverse neutral drive 4-3 pressure switch. This is going to be your park reverse neutral drive 4 pressure switch. And this is going to be your reverse pressure switch. All right, now this is an OEM PSM, but they're all made in Mexico, as you can see. It's a EC Delco, and this one's relatively new. I just pulled it out of the drawer so that we can do the test. The usual problems that are associated with these, can be anything from code P1810, which is a pressure switch assembly code. So if you're popping that, then you want to take this off and you want to carry out the testing that we're going to show you in a second. You can also have problems with communication between this and the PCM because the wiring harness is no good, or because the external wiring harness leading from the computer to the case connector is also no good. And I'll flash a chart as well showing the different pin locations for the vehicle harness connector so that you can test that for 12 volt input and 5 voltage signal, so that you can validate that the proper communication is occurring between the PCM and the case connector on the transmission. So all right, what we're going to do is we're going to go and turn our multimeter back on, and you want to first set it to ohms. I'll show you the ohms testing, and we'll do the voltage testing. But each of these pressure switches is going to put out a resistance value when they are energized, when fluid is coming up from through the valve body, from the case, through the worm tracks, and to energizing these pressure switches, it's going to kind of close the circuit. You'll achieve continuity, and that continuity will read out in the form of an ohm reading here on the multimeter. That was a horrible way of explaining it, but that's how it works. So I like to use a pencil eraser for this, and you could use a drift punch, I guess, if you want, but this is basically harmless. So what you're going to do is put your leads, both positive and negative, on either side of the pressure switch itself. And then you're just going to take your pencil and you're going to press down on the pressure switch to actuate it. And when you do that, the meter should go from the reading it has now, which is completely open, to continuity, which is going to probably give you a value between anywhere of I'm going to say 0.2 ohms to about 2.5 ohms. That's what I've typically seen. Anywhere in that range is considered fine. So if you have that come up, and then as soon as you withdraw pressure, you want to see this go immediately back to 0. Okay? If it's not, if it's kind of lagging, if it's still showing continuity after you've withdrawn pressure, then that would tell you that there's something wrong with the switch. If when you apply pressure and nothing happens, it still stays open like this, then that would tell you that something's wrong with the switch. Alright, so I'll start with the reverse switch, and then I'll kind of work my way. Well, actually, you know what? I'll start with the switch over here. This is going to be D4, and then I'll work my way left to right. Alright, so we'll go ahead and put our leads. Okay, I'm going to try to hold them steady, but you want to make sure you're making good contact. Let me see if I can orient this a little bit better. Alright, so you can see what I'm doing, and then we're going to go ahead and we're going to introduce some pressure. And we have a reading of 0.4, 0.3, 0.4, 0.2. And make note that as I'm applying, and varying pressure, the resistance value is varying as well. So that's another test that you want to kind of conduct, just to make sure that this pressure switch is reading as it should, or I should say it's functioning as it should. Alright, so that's going to be your D4. Now we're going to do low. I'm going to make sure I'm on it. 0.6, 0.4, 0.5, 0.6, 0.3. So I'm subtly varying my pressure, so you're seeing that here on the multimeter. Alright, next is going to be that park reverse neutral drive D4, D3. So same value, and all these pressure switches are going to largely read the same, or at least they should. You shouldn't see anything that's wildly different. Like you shouldn't see one of these read like 10 ohms or 50 ohms or anything like that. Alright, I must not be on it. 0.6, 0.5, 0.4, 0.5, that's good. So a little bit of user error there. So that was our park, reverse, neutral, drive 4. Alright, now we're on reverse. Alright, so same reading. So the pressure switches appear to be functioning fine. Now one thing that you can do if you're not sure, if you're getting weird readings, is look at these diaphragms and also inspect the seals. If the seals are real hard or the diaphragm is cracked, there's a whole bunch of crud in there, that'll throw off the reading, and it'll also cause the pressure switch to malfunction if the contamination is bad enough. So just be mindful of that. Alright, next, go ahead and turn your multimeter to voltage setting. And we'll get our leads. And then what we do here is you really test it for 12 volts, but we're not going to get 12 volts or anything like that. But we're going to go ahead and we'll test each of these circuits, and you want to put your power on circuit A or B or C or whatever, and then you want to ground it on something that's suitable. So circuit A, and hang on, let me reposition this thing. Alright, so that's 0.026, holding steady. Alright, that was circuit A. Now we're going to go to the pin corresponding to circuit B. And I know I'm being very, very clumsy here, very sloppy. So I think I'm on circuit B. Okay, as I'm moving the power lead with my right hand, it's varying here on the multimeter. Alright, now we'll do C. Alright, so the purpose of this test is to confirm or deny that you're getting some reading that's staying consistent. And if you're moving the probe around like I am, I mean, it's going to vary a little bit, but the main thing is you don't want to see nothing. Alright, with the probes just laying on the bench like this, it'll go down to 0.01, to 0 volts. Nothing's happening, obviously. So this should give you enough information to make an assessment on the condition of the pressure switch manifold, whether to keep it or whether to dump it. And I mean, they're not super expensive, but at the same token, I mean, why throw 40, 45 bucks away if you don't have to? Plus, you want to know if there's upstream problems. So by ruling this out, let's just say it's good like this one is, but you're getting P1810 anyway, then you know there's a problem somewhere else. Alright, so just to kind of summarize and wrap up, this transmission which is used is going to be part of the teardown inspection video that I'm going to film and post within about a week or so of the publication of this video. But we see that all of our electronics appear to be functioning the way they should be. Okay, now when we're talking about solenoid testing through the case connector, we're really only conducting half the tests that you really should conduct on shift solenoids, and a PWM solenoid is just like a shift solenoid. Basically, those solenoids can fail electrically, and they can fail mechanically. If they fail electrically, it'll throw a code for sure, because the computer will not see the proper resistance or the continuity or proper voltage, and it'll raise the red flag. But if they fail mechanically, that may or may not throw a code. Sometimes it'll throw a performance code, but sometimes it won't. And how you test for mechanical failure, it actually requires some very specialized equipment, which is totally not worth buying unless you do these things day in, day out by the gross. I do them fairly frequently, and for me it's not worth it. But basically how it works is there's a test block that uses shop air. It has air connectors going into the test block. Then it has receptacles for the shift solenoids, and you install the shift solenoids and you install the air source. And when you install the air source, you're going to hear a whole lot of hissing from air just rushing in. And then what you do is you set up like a 12-volt battery or something, and you take power probes and you energize the solenoid with that power source. And as soon as you do, that hissing and whooshing of air should immediately cut off, because what you're doing is energizing that solenoid. And so if it doesn't cut off, then you know the solenoid has failed mechanically, but it's still putting out the proper resistance when you're testing it with a DVOM meter. So again, it's not anything to lose sleep over. Shift solenoids are cheap. Even the OEM ones, they're not very expensive at all. And if you're doing a service on a transmission, whether it be a 4L60, 4L80 or whatever, let's just say it's a 100,000 mile service, you probably want to replace that stuff anyway. So this is more of for diagnostic purposes for a transmission that's not functioning right and throwing codes, or for the individual that is seeking a good used transmission to swap in place of a one that has gone bad and would require a complete overhaul or something. So now you kind of know what to test for, how to test it, and as you've seen, it all it takes is a multimeter, some alligator clips. I think these clips were literally like $5 on Amazon, and that's a whole set, not just these two, and some leads, and that's it. That's all you need. So hope this was informative. Hope this helped you with your 4L80. I'll do the same video for the 4L60s and for the Ford and Dodge transmissions when I can, but this should give you at least the knowledge that you need to go about trying to diagnose problems associated with the electronic side of these transmissions. So thank you again for watching. As always, I greatly appreciate you spending your time here on the channel. I know time is priceless and there's never enough of it. So again, I can't thank you enough. Enjoy the rest of your day or evening, and I look forward to seeing you in the next video.